Really excited to have Chris Full from Burnside. Welcome, Chris.
Thank you. Okay. Well, what an opportunity. Really excited to be here today and be able to talk to everybody about a bunch of projects that we work on, we have worked on in the past, related to erosion and sediment control during in-water works. One of them is going to be related to municipal drainage, and it's a bit of an oxymoron when it comes to erosion and sediment control, because we'll get into how that works. So just the outline here, we're going to go over an introduction. We're going to talk about erosion and sedimentation. We're going to talk about effects to receivers, so water quality, water bodies, water courses, types of ESC measures during in-water work, in-water works mitigation, some of the aspects of how we do our work so we mitigate, such as death of fish, impacts to wildlife. I've got a couple of case studies, a little surprise at the end, and hopefully some questions and answers. I want this to be collaborative. I think this is an opportunity that we can all discuss, and I don't feel like there's any stupid questions, because this is where we learn, right? And that's what it's about. So usually this is the hardest part because it's about yourself. And I feel really honored that I'm in this profession because I kind of live it. It is a lifestyle. It's something I was born with. Always wanting to be around water, dealing with fish, dealing with wildlife. Just that need to know and learn, right? It took me into going to Sir Sanford Fleming. I took a terrain and water resources technology. Got my diploma, first year geology. I kind of failed. It didn't go well, but I learned a lot from it. So I'm a senior aquatic ecologist with RJ Burnside Associates. We have about 430 staff, 10 offices in Southern Ontario, basically stopping at Pickering, but Wingham, Woodstock, new office in Hamilton. We've got Collingwood, Guelph, you're gonna miss one, Mississauga, Pickering, Newmarket, Barrie. I was fortunate to win an award for the innovation and design of the Barefoot Box Culvert through the Ontario Association of Certified Engineering Technicians and Technologists for technical achievement. That was in 2021. And as you can see, I'm a little passionate about fishing too, so there's a little bit of that goes along with what we do. So I figured I wouldn't have to talk about this because it would have already been discussed, but I think we need to get to the basics. I'm always about keep it simple, let's think about things, let's understand what we're doing, and start from the ground up. And it relates to understanding what soil and sedimentation, or erosion and sedimentation is. So soil erosion is the detachment and movement of soil particles by water, wind, ice, and gravity. Okay? And sediment is the result of erosion. And then sedimentation is the buildup of eroded soil particles that are transported in runoff from their site of origin and deposited in drainage systems, other ground surfaces, and bodies of water, water bodies, water courses, that sort of thing, and wetlands, which is a big deal. If you've ever had to deal with a sediment spill in a wetland, you'll never want it to happen again, because it's literally impossible to deal with. So I figured I might not even have to talk about this either, but obviously it's something that we can talk about because it's still new. The result of, and what is erosion and sedimentation? So precipitation, gravity, wind, hitting a ground surface that has loose soils, creating detachment. So detachment of the soil particles, gravity taking it as transporting, and into deposition, which would be sedimentation. And a bit of an overview of kind of a landscape type system where there's stream bank erosion, and what we're seeing in the upgradient areas, up on the slopes, we've got raindrop hitting exposed soils, not vegetated, sheet erosion coming down, and then creating these rills and gullies. Rills and gullies are transferring and transporting that soil that's been eroded into streams. It has to get to the water course, it is going to erode down, and it will impact your banks. Once it gets into the stream, you do have a problem. So some of the effects of erosion and sedimentation receivers obviously impacts the water courses and wetlands. As we discussed, you've got sediment that's going into those zones. It's getting into the, into the substrate. It's getting into the vegetation, and it basically smothers everything. Your invertebrates, anything that's living on the bottom, that critical habitat for fish is smothered, and that's a big situation. With regards to the morphology of the channel, it will change. So you have sedimentation, you have erosion, and then you have deposition. Now that impacts the channel itself from a morphology perspective, because now the water has to go somewhere else, and now it creates erosion in another place. So that is equal to loss of land. And in a drainage situation, loss of land is a big deal, but also, with regards to erosion, it's a major problem to the system. Also, what can happen is flooding. So you have erosion, sedimentation, now you've lost the capacity in your channel, and now that water has nowhere to go, and it creates flooding. With regards to release of sediment, it's called release of a deleterious substance. That's an infraction under the Fisheries Act, and that's offensible. So we don't want to have those things happen, and I come from consulting background, having the opportunity to work on a lot of different projects. So I get to work with contractors, I get to work with the regulators, I get to work with engineers. We see a lot of different things happen, and that's where I hope to share my experience. So I had to put this in because I thought we'd just start off with a laugh. This is for real. This is what actually happens. And I'm sure we've said, the rains are coming. And the contractors said, yeah, we're good. But are we good? We're not good. This is not good. And in this situation, it doesn't matter how many miles of silt fence you put, how much coir matting, how many straw bales, how many T-bars. It doesn't matter because you haven't dealt with your problem. What do you think the problem is? What's the problem here? All right.
Management of water.
Right. Exactly. So they didn't have a sediment basin. They did not have a place for their water to go, and when it runs off, it's got to go down gradient and it's going to go to your receiver. So you have to be able to control that water, at least hold it back, and sediment basins are an aspect of land development that's required. So they didn't have it in place, and obviously it didn't work. So types of ESC measures, just really ground up, we've talked about silt fences. So there's OPSDs for heavy duty, light duty. What I can say about silt fences, excellent product. I don't know if I like the mesh on the back of these light duty ones. It's not great for wildlife. Easily trap salamanders, frogs, snakes, turtles. They will try to get up this stuff because we've created a barrier. They want to go to the places that they're not used to going to, and then what happens is they get along that silt fence and then they try to get up it. So, the heavy duty filter fabric I think is really good, using T-bars, and also ensuring that it's properly installed. You can have miles of this stuff, but if it has one hole this big in the wrong spot, it doesn't matter how much miles of that you have because it's going into the water course. We talked about fiber rolls, so these are checks, silt socks, those sorts of things used in channels or runoff areas, and also along banks where you don't want soil to migrate or migrate out of where you're doing the work. Erosion control mats. You can see in this photo here, this is a small creek realignment. We took a pond offline just this last fall. We've got a lot of rock, obviously, in the area, and we're just really, under the gun. It was late season. We had to get a late work window, begged for a little bit more time because the ultimate effect would have been blow out of this pond and a major release of sediment into the 9 Mile, which is a very sensitive system. Just think about when you're applying erosion sediment control, think about layering. Like think about how shingles lay on a roof. You're starting from the bottom and you're working your way up, right? Because when the water comes off, it will shed, not take stuff away from it. So, or undermine. Cofferdams we'll talk about in kind of in waterworks type situations. I've got a couple of those, and turbidity curtains, which definitely helped us out on a project we're going to discuss. So this is a drainage type project. I think it's a little bit of an oxymoron that we talk about ESC and drainage, because drainage, they aren't required to bypass water. They're allowed to just dig in the channel. And when you dig in the channel, what do you think is going to happen? You're going to have a lot of sediment. And the reason you're digging in the channel is probably to maintain that drain, because it doesn't have the capacity anymore. And you are digging in that channel, taking out the fine sediments that are deposited there, and it's creating a mess. So this one's the South Innisfail Creek Drain. This project's 10 kilometers of channel improvement that we're currently doing. This is an outlet of a culvert that I'll talk about in a little bit. But just see, you know, you've got your stockpile here where the landowner didn't want that topsoil yet, so we've got heavy-duty silt fence, T-bars, stone protection along the bends and along the base and the toe of the slope, which we'll talk about. Really, at the end of the day, drainage, when it comes to landowners paying for something, they really struggle with the fact that you're putting something back into that drain. Like, they're paying you to take it out in their mind, right? But our concept and our thoughts are that let's develop drainage that is self-cleansing and that it's stable. Because if you just dig a trapezoidal channel and you hope that it stays and we get all these climate-related effects, then we're going to have problems. It is going to erode. So we're now getting people on track, and really, if it's written in the report, you can apply different techniques. So we're going to talk about some innovative techniques that relate to drainage. Some choir matting there. So in-water works mitigation with regards to drainage. So if we're not pumping the water around, and we have to deal with sediment, and we can't use, I've heard people talk about silt fences in the water course. It's like, what? We can't put a turbidity curtain across the flow. We got to figure out a way that we're going to deal with the sediment that's laden in the water, because they still have to dig. So I really believe sediment traps, which we've token pool riffles, which is opposite of what you would think, because it's usually riffle pool, is a means of being able to capture sediment and create an area that during maintenance is also used to remove the sediment. Staging the work from upstream to downstream. A lot of contractors want to work from downstream to upstream. But if you're working from downstream to upstream in flowing water, what's going to happen with sediment? It just keeps going into the places that you just cleaned, because you're liberating the sediment as you're working up the system. So work up downstream, upstream to downstream. Bank protection I talked about, and we'll talk about a few different applications. Big one is sod matting. And this is an innovative technique that we're gonna talk and discuss. And I've got a video with showing how it works. Turbidity curtains and obviously cofferdams, which you can see in this being installed. Whoops, that's not the right way. Big thing with cofferdams, if you are gonna use them, it has to have poly. You can have as many silk bed or sandbags as you want. If you don't have the poly there to keep the water out, then it's not gonna work. And it has to be on cohesive or material at the bottom that doesn't allow the water to come in. If you lay poly on gravel, you're going to keep wondering why water's going to come in. It's because the gravel's conveying the water. So, how is a sediment trap pool riffle designed? It's basically a large pool type excavation or area within the channel itself that has a riffle crest at the down gradient side with side stone that is elevated so it backs up the water. We like to use types of stone that is diverse in size, so it's not just the same kind of bowling ball. Because at the end of the day, we always struggled with this when we did natural channel design, and the regulatory agency said, we want clean round stone. Okay, clean round stone, 2 to 6 inch, clean round stone. You're going to develop your riffle out of clean round stone. Okay, we built this nice riffle, we've got the crest, we've got the down gradient, water's going over top, let the flow go. Where'd the water go? There's no water. It's in the voids. So you need to pack the voids in these riffles to actually allow the water to go over top. So having a diversified stone size and gradient is really important. And then what would be discussed in drainage is let's use riprap. But riprap we can't put below the high water mark. So why not use round stone, and then at the end, we grade it. Once we're done, we grade it, and it turns into an actual riffle that the fish can use. So here's a couple of photos, recently installed, obviously, brand new stone. That pool is the up gradient side, so upstream side, and then spilling over the top of the riffle. You want to elevate that riffle so you back up the water. You want it to slow down. So if you slow down the water, you allow the sediment to settle. This is the outcome. That's an older sediment basin there, and the water's a little high, but when the water's low, you actually get a riffle type condition. And in the South Innisfil Creek drain, I think we have grade of like 1% over 10 kilometers. So you don't have a lot of grade elevation to work with, right? You can't make riffle pools. It's just very flat, and you have to deal with what you have. So we talked about bank protection with regards to the stone. Typically what's required in drainage application, they are allowed to use riprap. And I'm just throwing it out there. I hope I don't offend any engineers or the OPSD, but let's stop putting filter fabric or filter cloth underneath riprap because it doesn't work. That water gets underneath. If it's anywhere near the water course, see these guys are contractors. I can tell you right now because they're talking about it and they know what happens, guys. What happens? It gets blown away, doesn't it? It gets pulled away. It tugs on that material, it lifts the riprap, and you come back and get paid to fix it. All right. So you're allowed riprap above the annual high water mark. We can easily vegetate it. We put it into the banks, the soil, the natural sets, like any of the seeds that are in there will grow up. And then once that matrix comes together, it creates a pretty strong upper bank. Below the high water mark, we're putting in round stone, so river stone. But in some of these situations in drainage projects, you've got landowners that have this pile of stone that they just want off the property because they want to grow corn. You can take that and use it. It's natural, it's there, and I think it's more about just understanding the size and making it work with the granular materials you have to get, which I do hear is very hard to get. Like, we're running into problems with, down southwestern Ontario, we're running into problems getting granular material for our streams because it's just not there. We have incorporated woody material into drainage projects because the South Innisfil Creek drain was a DFO authorization. And so under the DFO authorization process, you have mitigation monitoring and you have offsetting. So offsetting is determining or outlining what your gain in habitat or your replacement of habitat is going to be, and they gauge that and you have to monitor it. So in that situation, we had very steep banks, and we wanted to use woody debris as a means of providing fish habitat. Fish like wood. Landowners really struggle with the fact that you're putting something like that back in the drain, right? Because they want it all right. We'll talk about erosion control maps, we did already, So stone protection and woody debris. So we're talking about working and flowing systems. We'll leave streams aside. So we'll talk about streams right now. When you do a stream, a natural water course, you are pumping water around. You have cofferdam upstream and downstream. You isolate your area. You get effectively sized or suitably sized pumps where you take your water, convey it around your work area, and it's discharged downstream. You could use flumes, you could use a bypass channel, that sort of thing, but at the end of the day, you're not working in the stream without isolating it. In drainage, you're allowed to work as the stream is flowing. So one of the things that we want to do is we want to work at the front. So on the toe of the slope or at the bank, we want to work at the front so we create that barrier so that you can work behind it. So get that stone in. We're using keystones, a bit of smaller woody debris kind of intermixed with it. I think he puts round stone or some riprap there on the overbank, and then he used the sod matting on top. This is right after construction, and then that is 1 year later. So that's been vegetated, and it's stable. Here's another application. With regards to the stone protection at the toe of the bank, when we want to ensure, like this system was very sandy. It wanted to move around. We want to ensure that we're not having a release of sediment into the system. You've got to look at your areas that are eroding and protect it. So we use there was local woody debris, willow type material. We'll see if it grows. At the end of the day, it's something that's protecting the toe slope within the bank, or the toe of the bank. Incorporating meanders, not typical in drainage. They just want to see a linear trapezoidal channel. And the issue with this project was that there was massive flooding. They had downstream high quality market gardens. They're producing like baby food quality carrots, onions, potatoes. If their crops flood, I think it's for longer than 48 hours, it's done. And you can imagine what kind of cost goes into something like that. These are low-lying areas, similar to the Hall Marsh, right? We put these meanders in because it allows for the sediment to find its way. There needs to be natural migration of sediment because that's never going to end. Even when you dig down into some of these areas, there's saturated sands that will continue leaching into your system. Like it's going to continue coming into the system. You haven't stopped that sand from moving because it's saturated. It wants to come in. So the thought is having these meanders, having diversity, allowing for fish habitat, and then also allowing for deposition and natural processes to happen. This stone, this is right after it was built. So that was built in one day. And this will end up, this was just this last season. When we go back, we'll see, shoots of grass coming up through it. We'll see fine sediments getting into the voids, that sort of naturalization. So sod matting I've talked about, and we're going to get into it here. It's something I experienced probably 12 to 15 years ago. I will give all the credit to R&M Construction. They're a Dutch company, and they reuse everything. They will make chips out of trees. They always think about how to reuse what they have. They will take a shrub and plant it there. They won't be going away with anything. They won't be trucking anything off site. And what we got into was a very confined channel where we had to protect the banks. And they said, well, really at the end of the day, if we have to establish a root mass that is going to be capable of handling high flows, how long does it take to do that? Like, you have to have a serious root mass so that you don't lose your soils. So this sod matting actually is a means of using the excavator with available material, and it was kind of hard in Innisfil because we had a lot of sandy, fern-type condition, which would just break apart. And but the areas we could use it, good topsoil, 30 centimeters thick, 1 to 2 meters in length, and basically putting it along the tops of the banks and letting it fall over onto the rock toe slope and then pushing it in. It's bucket packed, like using the excavator and basically pushing it in as we go. So instead of me keep going on about explaining it, I want to show you a video. And this is a time lapse, R&D construction. We've got a terraced type channel right now, so we've got a terrace in the low flow overhang. We're using existing sod material, so he's excavating, and as he's saving that sod mat off to the side, and then he's placing it from the bottom of the bank and up. If you've never been in an excavator before, you're going to get an experience right now. So this is what it's like for him in really fast mode. But as you can see, in an area that we already have vegetation, like we're not taking this stuff off site, we're going to use it. So turbidity curtains, we're going to talk about how we mitigate during in-water works. And we've had a lot of talk about turbidity curtains. I think excellent product. It's in the streams and the water courses I've worked in, it's pretty hard to put them across the current. It's just going to get mowed down. You're going to see the water back up. It's going to want to go over top. So I feel like turbidity curtains are very useful on banks. Like when we're doing bank work where we can isolate the area and be able to tie it off, but still allow the flow to keep going, right? We never want to battle Mother Nature because it won't work. Like, you just don't win. So another thing I want to talk about is how we deploy those turbidity curtains, because we're dealing with fish and wildlife. And when we're in the water, if you just take the turbidity curtain and you just kind of bring it out and around on the bank, guess what you're doing? You're trapping everything that lives there. And in our systems, there's a lot. There's like, every time contractor sees what we have in our buckets after we've salvaged the entire section, blows their minds. They're like, there's nothing. Come look in the bucket. They're like, are you kidding me? I said, yeah, there's that. And then when you de-water or anything like that, there'll be twice that, right? Like that's how much is there. So the thought about deploying these turbidity curtains is from the shoreline out. So get it up along the shoreline and then inch it out from upstream to downstream using T-bars and get it into place, because that will actually exclude fish from your area. You're still going to have to salvage, but you haven't trapped them. Like's been discussed, you got to monitor the perimeter. Like there could be holes, they could put a T-bar through it. You can see that there's undermining. Even the flow will actually want to get into your turbidity curtain and start to scour underneath and bring that sediment. And you'll wonder, what's going on here? It's starting to get dirty, but I haven't done anything. But it's the flow actually taking that sediment and finding its way. And we talked about having it elevated. In our systems, in our streams that we're working on, we need to have it tight to the ground. We need to have it tight to the bottom. On one project, there was no release of sediment. Couldn't have any release of sediment. So the other one, people ask, well, when can we take it out? And DFO's preference is 24 hours. But really, what it boils down to is that the water quality is the same as it is outside as it is inside. Right? If it's still dirty in there and it's been 24 hours, well, guess what? You're going to have to wait. You should wait. This is a project on the Nonosaga River. I was watching Chinook salmon come up in August. So that timing window, they say, is the end of September. Well, in Nonosaga River, it's beginning, they come in as early as mid-July and into August. Fresh fish from the Georgian Bay up 60 miles of river. So this is a bank stabilization project with R&M. And effective use of the turbidity curtain. They have a few lines anchored off to the outside to keep it from getting bowed in. So I think you have to work with your site conditions. It's going to tell you, the river's going to tell you what you're going to need to do. This is basically a vegetated rock embankment all the way down. I'm standing on a bridge that was going to be, abutments were, and footings were getting undermined, so we had to reestablish that. I'm going to highlight a sediment removal project at the end, but here's a recent project last March where we are in the water using turbidity curtains to isolate sediment that has been released. And we're using a vac truck off the bridge to suck the sediment out. And for anybody who's ever going to have to deal with something like this, just be aware that a vac truck isn't the solution, because it needs air to actually move the material. It can't just go right into the water because it has no air that keeps the material moving. So. Pretty dirty. This was another one. That was a sludge pump. We'll talk about that one later, but I think just the aspect of that is a high quality trout stream. There's brown trout, brook trout in there. We had to deal with the sediment. So, with regards to mitigation, we also have to deal with fish and wildlife, and being effective in how we deal with them. You know, I can tell you the contractors don't want to hear that you're going to be salvaging fish for the next 2 days. You need to get in, get it done. You have to have a license to collect. You have to have good equipment, and you have to schedule it at the right time. If you get a 24-hour rain event or whatever before, and you think you're going to go in there with all your equipment and show up at site, even if they want you to get it done, it's probably not going to happen. So in the drainage world, we were able to use fish fences and barriers as a means to exclude fish from the work area. That was permitted under the authorization. And how we did that was we put a barrier upstream, we would seine net down through, exclude fish in the area, and then put the other fish fence down below that, like 1/8-inch metal wire mesh, T-bars, that sort of thing. So So here's a couple photos of how that's happening. T-bars to keep it upright. We're not in a high gradient system, right? So it's not too bad. There's the seine netting. Our electrofishing crew working at salvaging fish. And I'll be honest, just because you have a backpack on, you're not getting them all. When you de-water, like even at like culvert situations, we'll de-water. Even if you electrofish, you're probably going to miss 30 to 40%. But when you de-water and you seine net, or you use dip nets, once you de-water right to the bottom, you will get them all. But you have to have a fish screen on your intakes, and that's not just that muffler-looking like thing at the bottom. That is a full-blown, suitably sized DFO fish screen guideline approved intake, because the velocity that's coming in there is from training fish. So I want to throw this in, we get to work in the summer because that's the best time. I don't know, but you get those freak events, and you're never gonna, you can build a cofferdam, but don't expect to hold back the water when you get that big event. You're probably just gonna have to repair and get it figured out. I think if anything, don't build it so high that you're gonna create a major problem. Really? Okay, so, really? This is a bullpen. I'm gonna start ripping now. That is basically a filter bag that doesn't just work on its own. You need to have a filter cloth and a staked hay bale perimeter that can look really good. I think this is self-explanatory. You need to work with the contractor. You need to talk about what's going on. You need to understand the contract, and you need to work together to get it done. I think that's the message. So this is the case study. This one was just this last year. It was dealing with 3,600 cubic meters of sediment into a high-quality trout stream. It had brown trout in it, spawning activity. DFO ordered issues to all parties. Full cleanup required within 1 year. We got brought in as a third party to deal with the mess. Here, whoa, just a second. This is the mess. That's usually a 6-foot deep hole. This is some of the cleanup. And these two guys are your worst nightmare. Because they are the officers, and they're the ones that are questioning everything you're doing. And they want to know that you're doing a good job. And let's just say I felt like a bit of a punching bag, but I guess that was my fault. We had, it was an 80-year-old pond. We were able to get things back on track, worked with the contractor. This is the stream upstream as of a year old. We have trout living in it. DFO walked up through the entire thing, spooked trout all over. We were able to use large woody debris. At the end of the day, let's make it like a stream, okay? There's lots of OPSDs out there, but think about it. You need to think about what the fish want. 240 cubic meters was the largest sediment area that we had to deal with. We used a stabilization in place, so we used woody debris to stabilize that sediment because there was no way to get it out. Yeah, it was over 20 sets that we had to deal with. South Ennisville Creek Drain, I think I talked quite a bit about it. I'm not going to get into it too much. 10 kilometers. We have done an eDNA sampling program, baseline study before we did all the work, and we're going to hopefully compare that in the future to improvement of sensitive species. Let's see if we've done a good job. I'd like an opportunity to talk about the barefoot box culvert. I don't get a chance because we haven't been in COVID for a long time, and now we get to talk to people. And this is a little bit of my baby. It is a perforated precast box culvert that allows groundwater upwelling to happen in the base of the culvert. The groundwater upwelling supports fish habitat, critical habitat for brook trout. They need groundwater to spawn, and they will not spawn anywhere unless groundwater is there. Oh, just a second. Who knows what this is? It's hard to see. WC. What does groundwater love? What plant loves groundwater? Right. This is a barefoot box culvert. Here's watercress. So here's a little video, and it's about the performance of the barefoot box culvert. Hopefully the sound makes sense. can't sing. Not great. You want sound?
Yep, we got it.
You got sound?
I can hear.
All right, we got sound. So this is in Melanchthon. It was the first one ever installed. It was in 2015. Good success. These are brook trout coming out of the culvert. And these aren't little guys. These are decent fish. Any kind of spawning that happens, the males are typically territorial. Keep an eye on the right-hand side of the screen. This is a smaller male. Trying to find a zone. And you will see a little bit of predation happening. Predatory instinct, which is kind of neat. This is using a GoPro, so you come in, chase put a GoPro inside the culvert. I also saw some activity, so I put one under the water. This is time lapse. And I was sitting at the table with my daughter while she was eating a bowl of, let's say, Fruit Loops. And when I saw this, I put my hands up, said, "This is awesome." She said, "Can I have another bowl of Fruit Loops?" And I said, "Yeah, no problem." It's great to have spawning, but you need to have Young of the Year. And if you have Young of the Year, then you know something has worked. And you need Young of the Year inside the Barefoot Locks culvert. And that's recruitment to the system. So when people say, "Does it work?" I just have to show this. Thank you. These are links to, I didn't mention, Drains Done Differently by Burnside. We've got 2 publications. It's all there if you need it. It's all the innovative measures that we used in a 10-kilometer drainage channel. And I would love a question.
Questions for